welcome to a new edition of the Heat Treat Podcast. Today we have a good friend, Rich Otts, Heat Treat Manager of Linamar. Is that correct, Rich?
I'm actually the corporate heat treat specialist.
Corporate Heat Treat Specialist. Sorry about that. So we're talking to one of the biggest names on the industry, and actually Rich manages a bunch of heat treat facilities. I just read a little bit about your bio, Rich, that Gord was kind enough to send me, but I didn't know you started as a commercial heat treat in commercial heat treat, and then you moved out to captive. Is that accurate?
Well, I initially was when I was very young, 14 years old. I started working in a heat treat shop that was down the street. My next door neighbor was a manager of it, and I went in. That was called Steffler Metal Products. It eventually was bought out by Can-Eng, which is a furnace manufacturer.
Mm-hmm.
And after about 10 years of them running it, they decided that they no longer wanted it, so they sold it to Hinterleiter Heat Treating, which now has been sold to Bodycoat.
Okay.
So yes, that was a commercial enterprise. Linamar Gear Heat Treat is actually really a commercial heat treat. We do work for all Linamar plants, so we charge them just like we charge a regular customer. Okay. So they come in, and if we have problems, it's a problem for Linamar Gear or Linamar Heat Treat. So we're really a commercial heat treater, but in an in-house situation. So 95% of the work in the plant is Linamar. We do have about 5% outside work, but again, it is dealing with 25 or 30 different Linamar plants. So you can say it's an in-house plant, but it's not. It's really servicing a lot of different customers.
Okay, that's good.
Yep.
So that gives me a lot of perspective. So you have a full division, just and the core business is running heat treat for your sister or mother plant.
Right.
So
we do a lot of work for Linamar Gear. It's about probably 10% of our work, but the other 90% of our work comes from other plants outside of Linamar. We actually do work stiff cases and stuff. So when we're doing prototyping, we do all the prototyping up here, so that when it's all established, then we send it to work somewhere else if they need it.
It's like the heat treat design process and engineering center, and then you decide where specifications are sent to the plants or other suppliers. Because also, as I was telling you, Linamar is a big name in the industry, and actually, it's said to be one of the biggest heat treat installation worldwide, and that's my follow-up question. I know a couple of plants in Linamar, and you run quite a variety of furnaces and processes, but there's a very big plant in Canada that has a bunch of IQs, and I know a plant that is in Nuevo Laredo that has a bunch of LPC processes. So I'm curious just to talk about how do you think both technologies work on the gear side. We have podcasts about LPC against IQ, and I don't want to get into that, but I do believe that each part is receptive to different technology on a better scale when you come to the application. So some parts are more reluctant to atmosphere, and some other parts are more reluctant to LPC. What is your opinion on that?
I think there's a place for both. I think the advantages to LPC is that the parts are much cleaner, of course. Even though our parts are very clean now, we've designed ways of washing them and getting the parts close to as clean as vacuum carburetors. They'll never meet that specification. The other thing is IGO, intergranular oxidation. On vacuum carburizing, there is none. So if you're not grinding gears, it is a disadvantage to be using regular carburizing. Other than that, distortion, people say vacuum carburizing is better distortion. We use very hot oil quenches up to 350 degrees, and I would say we actually get better distortion than vacuum carburizing. The vacuum carburizing guys are now deciding to put oil quenches on their furnace for quenchability.
That's
because
big.
So, and the quenchability is not good in a vacuum carburizer. They can only do certain alloys, where we can basically do any alloy, and we can get the core hardness of the parts. So we think that the atmosphere furnaces are an advantage as far as general productivity. We do so many materials and so many different part numbers so many different specifications that we find it's very flexible with what we have.
And one of the other questions that I had against pushers against IQ, when you run a bunch of volume and single part numbers, the most cost productive way is to run on pushers, but you tend to have selected single chambers, no matter if it's RQ or LPCs. What's your opinion on that, on process cost and volumes of scales regarding
Well,
process and
a,
IQ single chambers against pushers?
a pusher furnace in our situation just wouldn't work. We run our case steps. We have about 35 different case steps we run. We run about 1,200,000 gears a month. So we run anywhere from 0.3 millimeters case up to 1.5 millimeters case. So you really can't run that in a pusher furnace. When they design pusher furnaces, they design it so that you run the same case steps all the time. The push has to be constant. So for our type of, we also do normalizing. We do quench and temper. We do annealing. So we have a lot of processes run these furnaces, which you cannot run in a pusher. So for us, for a person like GM that's running the same case steps, they can design their process and their prints around one particular case step. They can do that. But in a situation where ours, where every case step is different, we just can't do that. And we have a lot more flexibility. Pushers got 5, 6 different zones, so you got to empty that out. We have one zone we empty out, we can run something else in it. We can go from carburizing to quench and temper to normalizing, and it only takes a few minutes.
And based on that, I mean, it's Linamar gear, right? So mainly a bunch of gears, but there's a bunch of other applications regarding carburizing or low pressure carburizing. The new there's a lot of nitriding now FNC. How have you seen in since you've been doing this since you were 14, right? The evolution of gear technology and heat treat process on gears. It was a massive gas carburizing business. Then LPC came in the way. Now there's a lot of talks about nitriding and FNC. But now with EV, right? That there's the bigger gears are gonna be smaller, but on every motor. Do you have an opinion on that? How the market is gonna evolve? I can just share a little bit of what I do. I seen in my application and customers. As you stated, I do believe that there's gonna be still place for both. The specs are gonna become higher on distortion, on cleanliness, but I don't see like a process fading away. A lot of things have to be considered, like process cost. There's a lot of CO2 emissions as well, but as well some others applications are more capex intensive than others. So what's your opinion on that? I'm curious to ask.
Well, as far as the change in heat treating from when I was 14 years old till I'm 74 years old, the heat treating really hasn't changed. They've tightened the specifications up. They've put more criteria in, like no carbides at all. They no retained austenite or 30% retained austenite, but they put these specifications in to upgrade the heat treating. So that has happened. But as far as the heat treating itself, it's pretty well the same as it was in 1964 as it is now. The controls on the equipment is much better. You have much tighter controls. The operators are better educated than they were back then. The kids we get now are educated kids. They know how to use computers. They know they're much more intelligent than we were back then. And they want to learn. They want to learn the heat treating. Back in my day, you hired guys off the street. They pushed the buttons and made the furnace work, but they really didn't know what they were doing. Today, our guys all get metallurgical training. So that's kind of the difference. I think it's much more high tech now. I think in my day, it was always at the back of the plant. The heat treater was put back there, and nobody liked to go in there. Nobody wanted to be there. Today, I mean, my facility, this facility I'm in, is the cleanest facility. It's as clean as any machining plant we have. In fact, cleaner. The floors are scrubbed every day. We don't see oil anywhere. There's no dirt anywhere. There's no carbon anywhere. So I think that's what's changed. It's a much better environment, and people accept it much more than they did in those days.
Yeah, that also seems to be like a taboo, or when they talk about a heat treat shop, that it has to be dirty and fumes and oiled and, all parts, all around the place.
Yeah.
There are there are a lot, but there are a lot of state-of-the-art plants, but it takes a lot of discipline and maintenance. What do you think is the key to achieve that on a commercial heat treat shop? Because you have different commercial shops, right? But maintenance is a big thing.
Yep.
But what's the culture and discipline on the educating, creating the culture to have a clean heat treat shop that you very rarely see around?
Well, the way we've done it is we treat our heat treat plant like we treat our commercial or machining plants. So they're required to be clean. So we have 3 times a day a scrubber comes through and scrubs the floors. My maintenance people shut our furnaces down once a month for preventative maintenance. We burn them off regularly, 2 days a week, 2 days a month. We the operators clean their own furnaces. They clean the floors by their furnaces. You'll never see a part laying around on the floor. It just doesn't happen. If there's a part on the floor, it's either picked up and thrown in the garbage or put back in where it belongs. So you just don't see that kind of thing. And I think that, in a commercial plant, it's more difficult because you have probably a little more clientele or variation of clientele. But if somebody tells you it's impossible to keep it clean, it's not. Like I said, this plant is, I had a guy in last week from a supplier who was trying to sell me something, and he asked to see the plant, and I took him out, and he said he couldn't believe that this was an oil quench plant. He said that he'd never seen anything as clean as this in all his days of traveling around, and he visits 5 or 6 heat treats a month selling product, and he was astounded. And I said, well, a commercial heat treat plant can be the same.
And it's tend to believe that LPC is much more cleaner than
It is.
But also I've seen a bunch of LPC plants that are not well maintained, that they look worse than an oil shop. So that can happen, right?
Absolutely. And if you're not running your process right, you can get a lot of sooty parts and out of vacuum carburizing if you don't manage the processes and the equipment maintenance, and the carbon gets carried all over the plant, and it's worse than here.
So that's operation, but I know that your background is very heavily on metallurgy and engineering, right? So when it comes to quality and inspection, no matter which process it is, or carburizing or annealing, LPC, what are the key aspects in order to meet the specs in the lab? Also, the metallurgical lab, it's a big deal because we're measuring the results of what we heat treating, we're quenching, what we're normalizing or annealing. Can you talk us through the quality inspections? What do people have to take in consideration? What it's more important that takes a lot of effort and manpower? What's been successful, or what would you advise to the heat treaters that they're very good at the shop, but they always miss something and they let go a part that is not quality-wise correct?
Well, because we're working for our own plants, we have to assure that every part is in spec.
Correct.
Every part. And we do a lot of induction hardening too. This plant alone has 20 induction machines. So we do FNC. We have 5 induction or FNC furnaces. Every load we check is checked. Every one piece out of every load is checked. On
every part, you said?
Every load, one part is checked.
Oh, every load, one part. Sorry about that.
It's checked. If it doesn't meet all the specifications required on the print, it is set aside with a hold tag on it. Only then we call the customer and say, hey, look, we're 0.4 microns out of spec. What can we do with the load? And the customer will then sit down. What's the problem with it? What will happen if we use it? We explain that to him. We call the customer, his customer. If they accept them, we use them. If not, we scrap them. And that happens very seldom. I mean, the specs we get are very tight, but we hold them. We very seldom get anything out of spec.
So that was an easy question for you, since you have a bunch of experience. But when you're doing a development or engineering a process from the beginning apart, and it behaves not accordingly to the experience, and you have to make a variation to the spec, how do you address that since the beginning, right? Not to process apart like you do the other families, same type of steel, but sometimes you find a part family that is not behaving correctly, and you have to make a variation on the specification. How you address that back to the plant because that's where actually what metallurgists, they come to work in place. I mean, that's like their final test. That a part that is not behaving correctly, we got cracks, or we got some IGO, or I don't know, or not and we got some margin side above it. How do you go back to the spec and say, these are the lines, but we have to make a variation from the spec?
Okay, so what we do, we get the specification before the job ever hits the floor, and we'll get it maybe 2 or 3 years before it hits the floor. So we're doing quotes now for 2026, 2027. So we get all the specifications. They tell us the material they're going to use. They give us the DI of the material. We get all that information. We then get a bunch of us metallurgists together, and we look at all the information. We have a corporate metallurgist at our corporate office. We have 2 metallurgists here. We all take a look at those specifications, and we decide if they can be attained or not. And if we don't think we can meet those specifications, we call the design engineer and explain to him what he has to do. If he's got the wrong material, he's looking for too high a core hardness, and the material won't meet it, we tell him he has to change the material or change the specification. So we go through each individual line item, and we decide that we can meet that on the specification or we can't meet it. Once that's done, then the samples all come here. So they'll start developing samples a year before they ever get into production. So at that time, we get the same material. They do the same cutting on the same machines, and we just start checking for the chemistry, or for the distortion, for the microstructure. All that is checked on parts long before it ever hits the production floor.
And can you, because I have no experience on this, but when you call the design engineer, when you're receiving the spec, sometimes us commercial heat treaters, I mean, we get the spec and we don't question it. I mean, they say, okay, this is the process and this is the hardness we need, with the case step, go do it. And then we play around. But we never see the spectrum of the guy designing the part. What are they familiar with heat treat? How do they design a part? If they go like this type of steel, or normalizing, or annealing, how do they choose the process? Are they metallurgists, or are they mechanical engineers?
I think both do that. But they design, like we have our own design house, McLaren, so they do a lot of the designing, and there are people there, and they have a metallurgist there. They will put their specifications on the print. We'll look at the specifications, or they get specifications from GM, Ford, Chrysler, Rivian, whoever has it. They'll give us those specifications. So once we do that, we get the specifications here, we review them, and we question them. If there's problems with it, we question them back to either McLaren or GM, and we get a meeting with their people, and then we discuss it, and we decide what's viable and what's not viable.
And what about gear technology? There's a lot of talk about EVs. Do you have an opinion on that? What I'm saying is that the gears that we're treating right now with light gears, as we call it, for light auto motors, or then heavy gears for trucking, I see a bunch of capacity out in the market with these big pusher furnaces or a bunch of IQs, but the electrical gears are going to be so much smaller.
Well, that's not true. We do all Rivian gears, and their gears are up to 10 inches in diameter. And there's 2 large gears, and there's 4 small gears on each wheel. So there's still a lot of gears on.
There's a bunch of gears, but my question will be, are they going to be treated differently, or they're going to be under the same 4 processes that we just talked about: the nitriding, carburizing, gas carburizing, LPC? Well, what do you see the trend is going to be there in the gears? And everybody's talking that it's going to happen very, very soon. Do you have a time frame on your head?
Well, I think you're still going to carburize gears. The FNC is not going to take the place. It's used for light duty gears, for ring gears and things like that. But as far as big gears, they're going to use carburizing. All the gears we do for Rivian, for Tesla, we do Tesla gears in China, and all this stuff we're designing for Rivian, that's all pretty well carburized. I would say 90% of it's carburized. So I don't think that'll change for a long time.
Gas carburized, sorry.
Gas carburizing or vacuum carburizing. It doesn't matter, either one. But that's still going to be there. That's not going to change. the volume of work and the type of work is going to change, because in a transmission, you need a lot of shafts and clutch housings and clutches and that kind of thing. That's all going to go away. So that part of it's going to be gone. The transmission of electric cars, the four wheels, and they each have their own transmission from individual motors. So each one of those motor will have a cluster of gears on it, and of course that'll still be part of the car, and always will be.
And what are specifications? Are they tighter on EV gears than on the combustion engine?
Yeah, they are so far. Yes,
my question is, will CQ9 still rule the EV industry on heat treat?
It should. Whether it will or not, I can't tell you. It should. Whether Rivian and Tesla and those people will adhere to it and let us adhere to it, I don't know. At this point, they give us a specification which is very tight, and the inspection they require is much more stringent than what we get from Ford, GM, or Chrysler. They want a lot more checking done on each part out of each load. Of course, their gears have to take more torque because electric car has more torque. So they have to be designed a little differently than a regular transmission gear.
And about the torque, when we talked about night riding and FNC, I mean, they do the wide layer, and they and those processes are for wear resistance process. Right. When you need carburized when you have a torque, will that be accurate to say?
Yeah, usually. Yeah, and some of those light duty gears, they have a core hardness too. They use a 4140 or 4130 and a 5130, and we pre-harden them, and then we FNC them afterwards. So they do have some capability of torque, but the heavier gears as of yet have not been gone to FNC. It's all carburizing.
All carburizing. So and time wise, everybody's talking Europe, Canada, United States, not Mexico at this place. But whenever I go to customers, they say, there's a very big, quick push to change from normal gears to EV gears. But as you and I just spoke previously on this conversation, you're quoting stuff for 2027, 2030, and usually a lot of platforms are delayed. When do you envision that this transition is going to take place? Or when's going to be the intersection that volumes are going to get evenly, and they're going to move to a more dominant EV? Do you see it in before 2030, or do you see it in 2025? We just would like to get your impression.
Something has to happen in infrastructure. The big problem with EVs is because of the short distance you can run, and the problems with running in wintertime, in very hot temperatures. Sure. There's a lot of infrastructure has to be built in our societies to make them work. In Canada, they're saying in 2035, all cars that are going to be built are going to be gas, are going to be electric, and that gas cars will not be allowed. You can drive the ones you have, but you can't produce them here anymore. I think that's being way too optimistic. I can't see that happening. There's a lot of electric cars in Canada, but you see no infrastructure to charge them. If you don't charge them at home, sometimes you have to drive around for an hour to find a charging station. And so unless somebody's willing to spend the money on infrastructure, unless somebody's willing to spend the money on infrastructure, which would probably have to be the government, I don't know who's going to do it. Gas stations don't want to invest because the return is very, very poor. So again, I think it's a long ways off. I think we'll be starting to look at hydrogen cars before we get fully electrified.
That's a great point of view. Very interesting. That's a whole new conversation. Yeah, and now regarding also for these OEMs, there's a lot of talk about reducing CO2 emissions and going green. And I have a couple of customers that have expected their furnaces fully electric, no matter the process cost. Yeah. Do your customers, or do you see a market that it's able to pay the prices of electric heat? Running heating via electric than gas. I mean, natural gas is like the cheapest way up to get to temperature. For the type of stuff that we do, that is to heat up a lot of metal from ambient temperature to austenizing temperature. and then maintain it is very cost effective. I'm not saying green, right? Well, there's a lot of talks to switch to electric heating. What's your opinion on that, or what do you see that the trends are on the industry?
Well, they want something clean. Electric's very expensive. I calculate that electricity is about, to run an electric furnace rather than a gas furnace, about 30%, 30 to 35% more expensive than a gas furnace, which is a huge increase if you try to give that to the customers. But if everybody has to do it, then everybody has the same pricing. So it just means the car is going to cost more.
Sure.
So, I mean, our customers now are asking us to tell them how we're going to be green. And so we're now trying to find out how we can make our furnaces greener by putting electric elements in them. Again, you don't change the oil quenching. Even the vacuum guys are saying we just can't quench fast enough, so we have to get oil quenches in. And so you're always going to have that burning oil. Even though we wash it and we recycle the oil, you still have some of that oil burning off. That's always going to be there. So there's things you can fix, there's things you can't fix. And that's what you're going to have to tell the primes and the government. You just can't do it.
So yeah, I do agree with what you're saying. So basically, if we're pushed to go electric, process costs is going to go up because everybody's going to be pushed,
Yep.
right?
Yep.
And the consumer is going to pay the final price of the additional cost of when they're buying the car. Will that be accurate to say?
That's very accurate. That's exactly what has to happen.
Right. 2035, Rich. I have enjoyed a lot of technical conversation. I mean, you seems that you have covered it from engineering, a heat treat process, from a specification, how you run your heat treat plants, the state of the art. I've been told, and then we covered a lot of gear technology. Today, the future EVs. But you've been doing this since you're 14, right? And you're 74 now. So I always ask my guests, with guys with your experience that have traveled the world, have seen many applications, and talking to you, you really have a passion for heat treat, for metal, given its properties. But I do believe that we as an industry right now, we have a problem because we are not training or getting enough talent, young talent, as elder talent is retiring. What do you see that we need to do as a heat treat industry on that? Because right now, all of the new engineers, they want to work from home, work on a startup, on Facebook, or in a fancy industry, and I don't believe we're promoting that talent to work on these very interesting and very engineering careers as heat treat engineers. What's your opinion on that? On how we have to, fight against it as the heat treat community?
Well, the main thing is you have to have comparable benefits for a person that's going to get in the industry. In the earlier days when I did it, heat treat plants never paid very well. It was a dirty job. You went there and you came home with dirty clothes, and it was. Well, my mother, when I first got a job in heat treating, I come home dirty. She said, if you stay in that business, I'm going to cut your hands off, so you can't do it anymore. And I said, well, then you're going to have to cut my hands off because I'm going to do it. But the perception is it's not a good thing to get into for your life, for your full life. So people don't want to do it. So you have to convince people that there is a future in it, and that it is a good living, and that you do get good benefits from it, and that it's one of the industries that's always going to be there. There's always going to be heat treating. You have to have it. No matter what, you have to have heat treating. So, I mean, we used to have the same problem here. I've been here for 24 years now, and the first 10 years, we had very difficult time finding people. Now we take kids out of college, we bring them in, and we let them become heat treaters. And we have probably the best team of people you'll ever see. We have metallurgists, we have people that run the plant, we have that lead hands that can do everything. They can use a microscope, they can check metallurgy. So we teach them the whole gamut of what they can do here, and they become very, very happy with the whole situation, and they stay. We've got lots of our employees been here 15 years now, 10, 15 years, and they're planning on staying here. So you just have to convince them it's a good technology to be in, and that it's always going to be here. They worry that, it's just it's a dirty place. People don't want to work in it either. You got to clean them up. You
Yeah,
really
great.
have to make them clean places, environmentally safe, no smoke in the atmosphere. I mean, here, if we get a puff of smoke, where everybody's in alarm. So we have to make sure that we give them an environment that's nice to work in. It's properly lighted, it's properly ventilated, it's proper heating, all those things that old heat treats didn't used to have.
And the final question, if you could be able to go back in time and tell an advice to young Richard back in the days when he was 14 years old, uh, that you have learned through your entire career, now you're 74, what would you tell yourself that you have learned through your experience worldwide on heat treat? It doesn't have to be technical, right? But what do you learn through your career that it doesn't have to be anything with IGO or IOS tonight, but as a professional, right? That you would like to share with the new generation of heat treaters?
Well, again, when I started in this business, it was a dirty place and nobody wanted to do it, so you could get a job there easily. Today, we interview people for this job, and we don't just take anybody off the street. We interview people even for our racking, because we expect our rackers to become furnace operators and then at some point to be lead hands. So in my case, I wish I would have looked at it more as a career back when I started. I didn't look at it as a career. I looked at something where I could make money at and eat. So that was great. But today it can be a great career. And I think you have to convince people that it is a great career and that it's challenging every day. I come to work every day with the thought that if I don't learn something or I don't teach something, I've really wasted that day. And so that's what we convey to our people, that we want to learn something every day or teach something every day. And they kind of like that concept.
Thank you so much for sharing this personal story, and being great talking to you, Rich. I know you're a busy guy. You have a bunch of parts to heat treat. So just would
Not
like
my life's better than that now. I have a fairly good life. I have lots of people competent around me that do just about everything for me. So it's good.
So, Rich, great talking to you. Thanks for taking the time to do this. You're really giving something to the heat treat community that I appreciate very much. And uh, thanks for doing this. I wish I can actually walk through your shop and take a look at the state of the art of
Welcome anytime.
Thank you. So Heat Treat podcast audience, this has been Rich Ott, one of the most power players on the Heat Treat community, and he just shared all his secrets all the way back since he was 40 years old. Thank you for doing this, Rich.
Thank you.